Welcome to our tutorial on dimensional analysis. This technique is to be used to determine if your formulas make sense dimensionally. We want to see if the left side of this equation, for example, is equal to the right side in terms of units. A lot of times in this course you're going to have to remember formulas when it comes to major test, because in the multiple choice section you're not going to have a formula sheet, and you have to recall certain formulas like this one down below. And sometimes you might not remember if this is a t or a t squared, and you might want to double check to see if at least the formula makes sense in terms of its dimensions or units. So you do have to know what each of these variables stand for, and when you look at the worksheet there's a list on one side that will go through. If you look online, that tells you x stands for position, which is measured in units of meters usually, or length. So you can use L for length, or you can put it in its SI units, which are in meters. Mass, you can use capital M for mass, or you could put it in its typical SI units, which are kilograms. And time, capital T, is typically measured in seconds for SI units. So let's take a look at this first example, number 2. We have x here. This is position or distance, and this is measured typically in meters. And we want to know whether this is dimensionally the same on the right side here. We have A, which stands for acceleration, and acceleration is the change in speed over time, or it's the amount of distance, meters, all over the time squared, meters per second squared. Then we are multiplying this variable by t, which stands for time, and time in this case is squared, so put s squared. So we want to know if this side and this side are equal to each other, and if you look at this, s squared here and this s squared here cancels out, and the meters on the one side and the meters on the other side are correct. So this is dimensionally correct. Now, I know you're probably looking at this and saying, well, what about the half? You see there's a half up there. Does that mean anything? Well, it's just a constant. We're only really looking at units, so when we go through this process, we're just looking at the units of each variable, so neglect the numbers that are in front of it, like this 4/3 in the next example. Okay, now let's move on to B here, and the capital V stands for volume. And volume, I know in chemistry you probably called it liters, but in physics we usually think of volume as length times width times height, which is really like meters cubed or length cubed. And we want to know if this is correct on the right side. So 4/3 is just a number, pi is also just a number, so we have r, which stands for radius, and radius being squared, so meter squared. So is this dimensionally correct? And you can see that there's a meters cubed here and a meters squared here. This is actually dimensionally incorrect. So this formula is definitely wrong. So that means you've made a mistake. Probably this r squared should be an r cubed. Okay, so now you are prepared, hopefully, to go on to the dimensional analysis worksheet. You may want to look on the first example where I kind of go through, online at least, and shows you what the units are for each of the different variables that we use typically in AP Physics. Okay, and that's it for this tutorial.